I may have left my stapler on the
You cannot blame me.
table, but I've got some paper clips.
You have to get that one for more.
If you were in this class, I could keep Tyler one in class.
This is all of us.
If you and Tyler were in class. I like Anchorage.
Hold on. I want to go.
Okay. Thank you. Good morning. Sorry, we were taking up homework. So if y'all have anything that y'all need to send to me, if y'all have test corrections or anything like that, y'all can send them. Lucas, you can wait and bring, if you need to turn in homework, you can bring that the week that we return to co-op, or you can text me pictures of it, whatever. All right, let me make sure I've got that up right.
Man, I forgot to give you this section.
Okay, thank you. Right. So let's see. All right, yeah, so we're starting out in chapter 6. At the break, I'll go copy the tests and hand those out, and then I will email tests for those that need them.
This chapter doesn't seem that bad. It's not all the chapters.
That's how they all start.
Yes, every single one I started. This is really easy. And
And
by the end of 6-6, it's gonna be like the polygon divided triangle to equal the circle. I'm like,
You change it, we're gonna have higher.
okay.
Okay, so we'll go back and start at 6-1. We'll kind of do a quick little review of what we talked about yesterday. We were talking about a polygon. All right. So we're talking about polygons, and basically we just said that a polygon is a plane figure that meets the following conditions. It is formed by 3 or more sides that all touch at a common vertex. Okay, no two sides no two sides with a common endpoint are collinear. Each side intersects exactly with 2 other sides, one at each endpoint. Okay, and so each place that it meets is called a vertex. Plural is vertices. We talked about looking at the different pictures of what is and is not a polygon. We talked about how you name polygons based on the number of sides that they have. And if we have an unknown number of sides, we represent that with the letter N and call that an n-gon. We talked about a convex polygon is one where if you extended each of the sides would all extend outside of the shape. A concave is where it kind of caves in on itself, where if you were extending the length of the sides, it would actually run through the shape. So that's the difference in convex and concave. We talked about an equilateral means that all sides are congruent. Equiangular means angles are congruent. So when we talk about a regular polygon, we are talking about a polygon that has all equal sides and all equal angles. So it is an equilateral, equiangular polygon, and that's what we call a regular polygon. And then we were getting to the point we had just barely touched on interior angles. Okay, and so the first interior angle that we're going to talk about is a diagonal. And basically a diagonal is going to be where we where you go, you're joining two non-consecutive vertices. So you can see here where it says a diagonal of a polygon is a segment that joins two non-consecutive vertices. So when I'm talking about non-consecutive, okay, remember we said consecutive means side by side. So it means that when I'm talking about non-consecutive, I'm not dealing with vertices that are side by side, okay? So it's going from one vertex to another that is not one that it's already joining to by the length of a side. So if we look at our figure over to the right, if we were talking about consecutive, then obviously we're looking at QR is consecutive. But from Q to S and Q to T, those are non-consecutive points, okay? So if I'm looking at Q, the consecutive points would be to R and to P, okay? So those are what you call consecutive because they're one after the other. But to S and T, those are not consecutive. So when I connect those 2 points with a line, we call those diagonals. So it says, like triangles, quadrilaterals have both interior and exterior angles. Oh, real quick to mention, so a four-sided quadrilateral is going to have two diagonals. So how many triangles was I able to break that shape into? If I have two diagonals, I've broken it into 3 triangles, didn't I? Okay. So now it says, like triangles, quadrilaterals have both interior and exterior angles. If you draw a diagonal in a quadrilateral, you divide it into 2 triangles, each of which has interior angles with measures that add up to 180 degrees. Since you can conclude that the sum of the measures of the interior angles of a quadrilateral is 2 times 180 or 160. So when I break this quadrilateral in 2, I've got 2 triangles. We've learned that one triangle has interior angle measures of 180. Therefore, 2 triangles equals 360, which means that the interior of the sum of the angles of a quadrilateral is always going to be 360 degrees. So just like we've been able to solve so many times when we're looking for measures of a triangle, and we've always looked at it and said, hey, I know the sum of the interior angles is 180. Now we need to go ahead and memorize that the sum of the interior angles of a quadrilateral is 360. Okay, so that's something that you need to know. Sorry, I'm gonna clean my mask real quick. It seems a little blurry. Okay. All right. So we can see our interior angles means they are inside the quadrilateral. Theorem 6.1, the interior angles of a quadrilateral theorem states that the sum of the measures of the interior angles equals 360. So the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 plus the measure of angle 4 equals 360 degrees. Okay, so if I know 3 of them, I can find the 4th. Or if I knew, like if I had an equation and each of these, like if I had, one was x, one was x plus 1, one was x plus 2, one was x plus 3, I could put all those together, set it equal to 360, and then solve. So let's go ahead and take a look at an example that they've given us. Example 4 shows us that we've got our quadrilateral here. And so if we know that angle P is 80, angle S is 70, R is 2x, and Q is x, all I've got to do is use that same formula and set them up where I have 80, 80 plus 70 plus 2x plus x equals 360. Okay, so all I've done is taken each of my measures of my angles, add them together. So 80 plus 70 is 150, and 2x plus x is 3x, so I end up with 150 plus 3x equals 260. I'm sorry, 360. Subtract 150 from each side, and I've got 3x is equal to 110, no, 210. Divide by 3, so x is equal to 70. So when I look at if x is 70, what do I know that angle R is?
140.
140, because it's 2 times x. Okay, so all I'm doing is setting up an equation using the information that I know, using the theorem that says if I add all 4 of them together and set them equal to 360, that I can solve for my unknown. All right, that's it on this section. Okay, so let's go ahead and take a look. Number 1 on guided practice, what did we say the plural of vertex is? Vertices, good. What do you call a polygon with 8 sides? Octagon, good. The prefix octo means 8. Think about octopus. Think about your stop sign as an octagon. It's 8-sided. What about a polygon with 15 sides?
Pentagon.
Pentagon, yeah. Suppose you could tie a string around a convex polygon. Would the length of the string be equal to the perimeter of the polygon? What if the polygon were concave? And explain. So suppose you could tie a string around a convex polygon. So basically, when we talk about around, we're talking about going around the outside of it, not like around it, okay? If you put it around the outside of it and traced it along all the way, then would the length of that string be equal to the perimeter?
No.
Think about, okay, let's look at number 4. If I ran a string along here, and then I stopped it and put it along here, and I stopped it, I put it along here, and I stopped it, and here, and I stopped it, and here. And I just put, let's say I glued it down. Okay, I've glued down a piece of string all along the edges of my polygon. When I take it off and stretch it out, will it be the length of the perimeter? Yeah,
Yeah.
it will be. But if I have, what if it's a concave polygon? What about this one? Because this one's concave, right? If I extended these sides out, it's going to cut through. So either way, yeah, either way. Okay, so let's look at number 4, 5, and 6. Is each figure a polygon? Why or why not? What about number 4?
Yeah.
Why? It's got sides. It's all touching at each vertex. There's nothing that is, we don't have 2 points that are collinear. So it is. What about number 5?
No.
Why?
Because the angle is fine.
Okay. Okay, so here I don't have a straight side. Okay, remember my sides, when we talk about a side, we're talking about a straight line touching from point to point. Here I've got that curve. What about number 6?
No,
Why?
because all sides do not touch.
Yeah, it doesn't touch. Okay, good. Now let's take a look, and it says, tell whether the polygon is best described as equiangular, equilateral, regular, or none of these. Okay, so let's look at number 7.
That would be angle.
Now think about if I have one arc here and 2 arcs here, do those represent the same angle measure? No, these are different angle measures, so these are not equiangular. What is equal about this one?
Equilateral.
Equilateral. Remember, lateral deals with sides, so it is equilateral. Let's look at number 8.
No.
Okay, what do I know about this one? I know that these two sides are congruent. I know that these two sides are congruent. I know that these two angles are congruent. But what about this angle and that angle? Are all of these the same angles?
No.
No, so it's not equiangular because all of the angles are not the same. It is not equilateral because all of the sides are not the same. So it's none of these. Good. Look at- Okay, let's look at 9. This one's equiangular because every single angle is the same measure because it's marked by the same symbol. What do I know about the sides?
They're all equal.
They're all equal. So those are equilateral. What did we say we call a polygon that is equiangular and equilateral? A regular polygon. Good. So remember, pay close attention to your symbols. Think about what you know. Now let's go ahead and look at number 10. Use the information in the diagram to find the measure of angle A. All right, I know 3 measures. I do not know the 4th. What is my equation that I can set up to find my missing angle?
X plus 125 plus 70 plus 60 equals 360.
All right, so we're using the sum of the angles equals 360. So X plus 125 plus 70 plus 60 equals 360. What is 125 plus 70?
195.
195. What is 195 plus 60?
155.
255. Good. So X plus 255 equals 360. Take away 255 from each side. So X is equal to 105 degrees. Is that right?
Mhm.
Is that right? 105?
Just add 5, you have 260, and you add 100.
Huh?
Just add 5 to 65, and then you add 100.
Okay, so 105. So in this part of the homework, the first section, practice applications, actually, let's just go through these. Let's not even worry about doing 12 through 17 in homework. Number 12, polygon, not a polygon.
Yes.
Yes, is it convex or concave? If I, did somebody say? If I extended my sides, what would happen if I extended this side this way? Does it go through the figure? Yes, so if it goes through the figure, it is concave. Good. 13.
Pentagon.
No, but 13, is it a polygon? No, does it have interior angles?
Oh.
No, so we don't have sides joining. We have them all intersecting. 14. No.
No.
15. 16.
Yes.
Yes, 17. So the only ones are 12 and 16. 12 is concave. What is 16? Convex or concave?
Convex.
Convex, good, because all of my sides extend outside the figure.
Could we call a circle an n-gon? Could you call it that?
Could you call a circle an n-gon? No, because remember, an n-gon has an unknown number of sides, and a circle doesn't have sides. All right, let's look at 16 through 20 real quick. Convex or concave? Number 16. I'm sorry, number 18.
Okay.
Think about if I did all my sides. Do any of them extend inside the figure?
No.
No.
On
What about 19? What happens when I extend my sides? It's concave because those lines go through it. What about 20? It's concave too, because notice just that little bitty divot over here, okay? Look, that if I were to extend this side out, not that one, well, this one, And then this one would end up going through, okay?
Wait, what was 19?
19 was concave, because notice if I extend this side, it's going to continue through the figure. And same with 20, that little bitty part, that little bitty divot right here. So this side would extend through and this side would extend through. All right, so homework. We will do numbers.
And this will be due after the break.
Yes, this will not be due. So basically, I would like you to have it completed by our next class, which will be the Wednesday after Thanksgiving. So you'll need to have the work done, but you won't hand it in until that Monday. That's our last week in class before Christmas. Okay. So you're going to finish it earlier than you handed in. All right. So let's do numbers 21 through 35 odds. 21 through 35 odds. And this is on page 326. 326, 21 through 35 odds. And then on 327, 37 through 45 odds. So 37, 39, you're finding the measure of angle A. 41, 43, 45, you're having to solve for X. You're going to be using the same formula that we did earlier, where the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 plus the measure of angle 4 equals 360. So you're going to be doing that on each of these. You're going to be using that theorem that that you add the sides to equal 360.
Can you repeat page 327?
So 320, let's see, 326 is going to be 21 through 35 odds. And then 327 is 37 through 45 odds. So basically we've got 21 through 45 odds. 21 through 45 odds.
What is a nonagon?
Wait,
An n-gon and a nonagon are different.
What's the name going again?
N-gon is when we do not know what it is. It's letting a variable represent the number of sides. Yeah.
I think I'm non.
Okay, so 6.2, properties of parallelograms. Okay, so it says in this lesson and the rest of this chapter, we're dealing with special quadrilaterals. A parallelogram is a quadrilateral with both pairs of opposite sides parallel. Both pairs of opposite sides are parallel. So when we look at our diagram, notice that for these two sides, I have a single arrow. That means that these two sides are parallel. I have double arrows here to make a distinction. So I can see that QR is parallel to PS. So my double arrows are parallel. My single arrows are parallel. Okay, so a parallelogram, in the name, it's telling us that I have sides that are parallel. Two pairs of opposite parallel sides, okay? When you mark diagrams of quadrilaterals, use matching arrowheads to indicate which sides are parallel. For example, in the diagram at the right, PQ is parallel to RS and QR is parallel to SP. The symbol with the little symbol PQRS is read parallelogram PQRS. So now we can see we've got a symbol to represent a parallelogram. Remember, we've talked about how our little two arrows like this mean parallel. So when you don't have to write out the word is parallel to, you can just do your two little lines. So you would have basically, you write the letters of your signs and the letters of your points with a line over it. You've got your parallel symbol, the next 2 points that make a side with a line over it. So that means side PQ is parallel to side RS. Okay, so symbols are something that we really that really help out as far as the shorthand in geometry. And now we're learning a little symbol that our little slanted rectangle represents a parallelogram, so you don't have to write that word out. Now notice, remember we talked about naming a parallelogram or naming a quadrilateral, and we want to name our letters in consecutive order, okay? So in this particular one, usually you're going to see them named alphabetically. So P, Q, R, S, but I'm going to go in order. If I said S, P, Q, R, that would be fine too, but usually you're going to start and you're going to go in alphabetical order consecutively. All right, so we have theorems about parallelograms. The first one is if a quadrilateral is a parallelogram, remember our if-then statements, then its opposite sides are congruent. Okay, parallelogram, opposite sides are congruent. Theorem 6.3 says if a quadrilateral is a parallelogram, then its opposite angles are congruent. So now we've learned that a parallelogram has opposite parallel sides and it has opposite congruent angles. The next one, if a quadrilateral is a parallelogram, then its consecutive angles are supplementary. First of all, what does consecutive mean?
The same?
No, consecutive means side by side. So if you look in this example they've given us, P and S are consecutive. What side is also consecutive with P?
Q.
Q is also consecutive. So P and Q are consecutive, P and S are consecutive. And I can add those two angles, they are supplementary. So what does that mean? They add together to equal 180. Supplementary angles equal 180, okay? Two pairs of opposite sides are congruent. Opposite angles are congruent. Interior angles that are consecutive are supplementary. The next thing is, if a quadrilateral is a parallelogram, then its diagonals bisect each other. So a diagonal means it goes from one vertex to the one across from it. And what does the word bisect mean?
Cut it in.
Cuts it in half, okay? So when those two diagonals cross each other, this one bisects PR, so that means this one's cut in half. Diagonal PR bisects QS, so that means it cuts it in half. So again, if I know that, then I can look and say, hey, I know these two are congruent. I know these two are congruent. So if I know the measure of one, I know the measure of the other. If I know the measure of one, I know the measure of the entire length of the diagonal as well. So four things, if quadrilateral is a parallelogram, opposite sides are congruent, opposite angles are congruent, consecutive angles are supplementary, diagonals bisect each other. Okay, so those are four very important things that you need to go ahead and memorize. All right, so let's go ahead to example 1. So it says FGHJ is a parallelogram. Find the unknown length and explain your reasoning. Okay, so we are looking and we want to find the measure of JH. So if we're looking at JH, how can I figure out what the length of this is? How do I know the measure of JH?
It's
All opposite sides are congruent.
Opposite sides are congruent. What is the measure of FG?
5.
So what is JH?
5.
Good. All right, the next one is JK. Let's look at JK. So notice JK is right here. Okay, how do I know the measure of this?
The diagonals of a parallelogram bisect each other.
Okay, so because they bisect, and I know that this side is 3, what do I know this side is?
3.
So what's the length of the entire diagonal?
6.
6. This one's 3, so this one's 3. That means the whole entire thing is 6. Okay? Let's go ahead and take a look at example 2. Again, using our properties that we just talked about, we need to find the measure of angle R. What is the measure of angle P? 70. What is the relationship between angle P and angle R?
Opposite.
They're opposite angles, so what does that mean the measure of angle R is? It is also 70, okay? So how can I find the measures of either Q or S?
Consecutive angles.
Consecutive angles are equal to what?
180.
180, so 180 minus 70 is equal to
110.
110. So I know that Q is 110 and S is 110. Is everybody following? Is everybody comfortable with understanding that opposite angles are congruent and consecutive angles are supplementary? So even if I just know one angle in my parallelogram, I can find all 4. Let's look at example 3. Again, I've got that S is 3x and R is 120. How can I solve for X? What equation can I use here?
Oh, substitute 3x for s and 120.
Okay, but what is my equation? How can I solve for X? What is the relationship between angle S and angle R?
Oh, you set them equal to 180 because the angles are supplementary.
They are consecutive angles. They are side by side. That means they are equal to 180. So if I add 3x plus 120, that equals 180. Okay, remember consecutive angles are supplementary. So 3x plus 120 is 180, subtract 120. So 3x is equal to 60, divide by 3, divide by 3, x is equal to 20. So now I found that x is equal to 20. So what does that mean the measure of S is?
60.
60, because we said x is 20 and 3 times 20 is 60. So we know that is 60 degrees. Okay. Let's look at goal 2. Proving facts about parallelograms. Okay, so let's take a look, and it says ABCD and AEFG are parallelograms. So the first thing I'm going to do is let's go ahead and highlight ABCD. So that means I'm talking about this one right here. Okay, and then AEFG. So we're talking about these as 2 different parallelograms. This is one going from side to side, going horizontally. Then I have one running vertically. It tells me that these are parallelograms. Therefore, I know that all those 4 rules that we talked about a moment ago, opposite sides are congruent, opposite angles are congruent, diagonals bisect each other, and consecutive sides are supplementary. Those 4 things that we just learned earlier about all quadrilaterals are true to each of these. Okay? Therefore, it says to prove that angle 1 is congruent to angle 3. Take a look at this. What do I know based on my polygon rules that we talked about a moment ago? What do I know the relationship is between angles 1 and 2? Why? They are opposite angles, so angle 1 and angle 2 are opposite angles. So they're congruent, right?
So wouldn't angle 1 be consecutive compared to angle 3 because of the transitive property?
We're getting there. Good. Okay, so we said that we know that angle 1 and 2 are opposite angles, so they're congruent. What else do I know about angles 2 and angle 3?
They're congruent.
Okay, same thing. They're opposite angles, so they're going to be congruent. So that means that angle 1 is congruent to angle 2. Angle 2 is congruent to angle 3. So what does that mean about angle 1? Well, how does that make angle 1 congruent to 3? What did you say, Houston? The transitive property. Okay. So notice we didn't even have to write out a whole proof about that. We just looked at the figure and said, what do I know about these relationships? That's basically what a proof is. Okay. Like I said, I'm not going to stress out about let's put it in the right order, in the right column, in the right way, that kind of stuff. I just want you to be able to look at it and say, hey, I know that 1 and 2 are opposite angles, so they're congruent. 2 and 3 are opposite angles, so they're congruent. So therefore, if they both have that common angle of angle 2, that transitive property tells me that 1 is congruent to 3. Okay. Let's take a look at example 5. Again, it says where that ABCD is a parallelogram, therefore, those 4 things that we talked about, opposite sides are congruent, opposite angles are congruent, diagonals bisect each other, consecutive angles equal 180. And we need to prove that AB is congruent to CD and AD is congruent to CB. Okay, so what do I know about my figure here? What's the only thing that I know for sure?
Oh, they're equally angular. The triangles are equally angular.
Okay, so I know that I've got 2 triangles. My triangles, now, how do you know they're equiangular? Are they marked?
No.
So can I assume anything?
No.
Knowing that this is a parallelogram, let's go ahead and mark this up. What do I know about angle A and C?
That they are consecutive.
No,
sides.
A and C. A,
Opposite sides.
they are opposite angles. Okay, so what do we know about opposite angles of a parallelogram?
They're congruent.
They're congruent. So I'm going to go ahead and put 1 arc for each of those to symbolize that they're congruent. What about angle B and angle D?
Also.
They're also congruent. They're opposite sides. I'm going to go ahead and put 2 arcs because they are not the same measure as A and C, but they are the same measure of each other. What do I know about the distance of AB and the distance of DC?
They're parallel.
They are parallel, okay, but what do I know about their distance? The length of them. Starts with a C. They're congruent, right? So AB and DC are congruent. AD is congruent to BC. So notice all we had to do is mark up. What do we know if we were to draw a diagonal from A to C? Okay, it bisects, so it cuts my diagonals in half. So there's all kinds of things that we can look at and know because they told us that this is a parallelogram. Because they said the beginning, the given, they've told us that for sure this is a parallelogram. I don't have to make any assumptions. So I go through my 4 rules that I know, and so I know my opposite angles are congruent. I know that opposite sides are congruent. And so it's trying to, it wants us to prove the congruency. So you can see here, ABCD is a parallelogram, that's our given. So it says to draw BD. So that was already drawn for us in red. And it says through any 2 points, there exists exactly 1 line. We have our definition of a parallelogram here saying that AB is parallel to CD and AD is parallel to CD. Therefore, we have alternate interior angles theorem telling that they're congruent. So we marked those. Therefore, and we can also see that DB is congruent to DB by the reflexive property that when I drew that diagonal. Therefore, if we look at our 2 triangles here, okay, if I take this diagonal away and we can just focus on this triangle here, what do you notice since we said that this side is congruent to itself? Notice I've got side, side, side congruence, okay? So that's how we're able to prove that these 2 triangles are congruent And so corresponding parts of congruent triangles are congruent is the final there.
Oh, could it also be angle side angle?
You could, yes, I'm sorry, you could use angle, side, angle. So notice that's what they used was angle, side, angle. So remember, angle, side, angle, or I could have angle, side, angle. Okay, so there's all different ways to use that. All righty. You can see where we've got just in furniture design, using parallelograms in real life, that, you know, looking at the slope of a table, you could calculate that. So you can see how the base is made into a parallelogram, which is broken into triangles, which gives us the slope. All right, so there's the bell for break. When we come back, we'll go through the guided practice and look at the next section. I'm going to run copy our tests. Yay.
Stop it, John, stop.
Okay.
Let me guess.
She thinks that you're polite.
She hates the table with me, Chris. Yeah. They're all white. It's fine. Yes.
She's like laughing.
I was like, are you kidding me? I was like, oh my god. It was just like right in that classroom, right?
Tyler, are you pulling?
Yeah, Zoe one time punched a 6-year-old because he did it. Who? She punched him. His name was Benjamin. Who punched him? Zoe punched Benjamin when he was like 6. Because he why don't you punch him?
No. Oh, yeah.
Zoe. There we go.
Yeah, you're pretty close. Hey, Lucas is pulling food.
Who?
Yeah.
Oh, I love you. I'll get to a week after this.
So you did it, Lydia?
What?
From our class?
No, Lucas is pulling food. Not that Lydia.
Oh,
Yeah, I can't pull. I just can't do.
can't what?
Get a girl. It's impossible. It's impossible. You gotta like, you gotta either
Yo,
be an
all
athlete
you have
or
to do is just
good
wait
looking.
till you have. Yeah, all you wait till you have full coverage.
No, that's- Oh, yeah. I have to see that.
Here,
Wait, I'll take a picture of this girl. But post it, dude. Oh,
here, all you have to do is just wait till you get full coverage. That's it.
that is actually the worst idea.
That's the
somebody
only
would
way
have.
that
You know how bad that sounds?
That's the only way to go full. Oh, what you're saying.
Nah, it'll be fun.
Dude,
Did you watch an anime?
Yeah.
Yeah, it is.
Garrett,
Yeah.
Alec told me that Zoe, like, running up our class, alright, punched a kid. Like, she not bring her arm when she did that.
She's just a little girl, trust me.
Did she legit punch a kid?
Dude,
Oh yeah, she punched him in the gut.
Who was it?
And like the 6-year-old.
dude, her arms like this.
I bet she could beat you in arm wrestle.
Yeah.
Yeah, I believe she could be. She probably beat me.
She looks like one of those really, really thin meat girls, but she's like the opposite of that.
She probably watches like the motivational 69 video. Where it's like, just snitch on everybody.
Right.
No one else. This is it.
But it's
Lucas,
Look at
Lucas, 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 Lucas. Hey, buddy,
Somebody
turn your
else-
camera on.
Somebody else.
I'm stupid. Hey. Hey, buddy. Hey, hey, are you pulling? Are you
Pulling?
You in the car? Where are you? Where are you?
Car.
You in the car?
No, I'm in the car.
Yeah, you're in the car. You didn't answer my question. Are you pulling?
My what?
Are you pulling? This is
No.
important information.
I said no.
Never mind, buddy. I'll get it later.
I
Important information.
I mean, he was asking what this was. Like, apparently you got
know from home.
not to see them.
He should see him one eye.
Because he said he didn't.
Oh, he lied.
You asked him 3 times.
Lucas is humble.
Okay, so we just looked at our parallelograms. So let's think about what would if you had to give the definition, if I was giving you a verbal test and said, hey, what is the definition of a parallelogram? What 4 things would you tell me? Or actually, let's go 5 things.
Parallel
What parallel?
sides.
How many?
5.
5 parallel sides?
4 parallel.
And they're all parallel to each other?
Yes. No. 2 sides are, wait, 2 sides are parallel to 1 and.
Okay, so we have 2 pairs
Yes, that's what it said, 2 pairs.
of parallel sides. Okay, 2 pairs of parallel sides because it's a 4-sided figure. That's number 1 is a 4-sided figure that has 2 pairs of parallel sides. What else do we know about it? What else does it have 2 pairs of?
angles.
What 2 pairs of what kind of angles? 2 pairs of congruent angles. So 2 pairs of parallel sides, 2 pairs of congruent angles. What else? What do I know about the diagonals? Diagonals of a parallelogram, what do?
Bisect.
They bisect each other, okay? And then their consecutive angles are supplementary. So anytime I am trying to test a figure and determine if it's a parallelogram, I know that those traits have to be there. It's 4-sided, first of all. It has 2 pairs of opposite parallel sides. It has 2, the opposite angles are congruent. Diagonals bisect each other, and consecutive angles are supplementary. Okay, so all of those things are going to be true about a parallelogram. Let's look at number 2. It says decide whether the figure is a parallelogram. If not, tell me why not. So let's look at this figure. Does it have 4 sides? Yes. Okay, so check. Does it have 2 pairs of parallel sides?
No.
No.
Yeah, no.
So it is not going to be a parallelogram because these 2 sides here on the opposite sides here are slanted. Therefore, they are not parallel. If I extended them out, they would intersect at a point outside the figure. Okay. So they do not have opposite sides parallel. Let's look at number 3. Is it 4-sided?
Yes.
Yeah. Do I have 2 pairs of opposite sides that are parallels?
Yes.
And so because they are parallel, because I can see that, I can also look at my opposite angles that would be parallel. Now, what if I drew a diagonal from here to here and a diagonal from here to here? What would happen? They would bisect each other, so it is a parallelogram. All right, so looking at our figure, identifying congruent parts. So it says we're using the diagram of a parallelogram and telling what would be congruent. So let's look at JK. What side is parallel to, or I'm sorry, what side is congruent to side JK? ML, good. What about MN? What is
KN.
congruent to MN?
Hey,
KN. Number 6, what about angle MLK?
KJ.
So MLK is going to be congruent to KJM. What about angle JKL?
LMJ.
LMJ or JML, either way, good. What about side JN is congruent to side, or to, yeah. So JN is congruent to
LN.
LN. KL is congruent to
JM.
JM. Angle MNL is congruent to
KN.
KNJ, and angle MKL is congruent to
J.
So we've got MKL is congruent to which one? JMK or KMJ. Good. All right. So again, if you cannot see those things, draw the figure, get a colored pencil and color code them if it helps you to see it better. All right, so it says now find the measure in the parallelogram LMNQ and explain your reasoning. So what is the measure of LM?
13.
Why?
Because it's parallel to QN.
Okay, parallel to QN. 13, LP.
7.
Why?
Is parallel to PNP.
And not parallel, but it's going to be congruent to NP, okay? Because that's a diagonal that has been bisected. Because it's bisected, I know that each side is going to be, or each segment will be 7. What about LQ?
8.
Why?
Because parallel to MN.
Parallel to MN, good. What about QP?
8.2.
Why?
Because it's congruent to NP.
Why?
Because it's bisected angle.
A diagonal that's been bisected. What about the measure of angle LMN?
21.
Look at LMN.
21.
58.
Why do you say 58? Notice this is 29 right here. Just this 29. This entire angle is not 29. This is a bisector. So what does that mean? Each of these angles equal. So this one and this one equal what?
80.
So take a look. What is the measure of angle L? 100. So what does that mean? How can I figure out this entire measure here? Okay, so I know that when I add L and Q, angle L plus angle Q is going to equal 180, right? These two together will equal 180. If this one is 100, how much is this total measure of Q? What is 180 minus 100? 80. What is this little measure here? 29. So I've got 80 minus 29. So then that means this little segment here is going to be, did I do that right? 10 minus 9 is 1, 10 minus 2 is 5. That little angle is going to be 51 degrees. Do you see how we did that? I had to take the knowledge that these two added together will be 180. This one is 100 degrees. That means this one here will be 80. I know 29 degrees, so 80 minus 29 is 51. Okay. Now let's take a look at angle NQL. So what do we say the whole measure of NQL is? 80 degrees. Good. What about MNQ? MNQ is going to be what? 100 degrees, good. Why? Because opposite angles, good. And what about LMQ?
151.
No, we're doing LM, oh wait, sorry, LMQ. Let me do that in a different color real quick. So I'm talking about LMQ. So I'm talking about this angle right up here. So what is it going to be? 29. Okay. Also in this situation, think about if we've got two parallel lines and we've got this angle coming through here, what's that called? A transversal. Remember when we have our transversal, we have alternate interior angles are congruent, alternate exterior angles are congruent, all that good stuff, all those rules from the beginning. So I can look at that and see that that would be 29 degrees right there, which means this one is 50. Okay, so thinking through all of these rules that we've talked about. So your homework in this section will be, let's do 21 through 37 odds. 21 through 37 odds. Let me look real quick. Did I write odds on the last homework? Yes.
Did you help on page 33?
Say that again.
Could you explain a little bit on page 33?
Okay.
Problem 33.
Number 33.
On how
Okay.
to solve the V over 3.
Okay. So let's look at number 3. What do I have in this situation? What have they given me measures of?
3.
Each side of my diagonals, my bisectors, okay? So these have been bisected. So what do I know about this side versus this side? They're equal to each other. They're congruent. So I would have 2u plus 2 is equal to 5u minus 10 and solve for u. What do I know about this side and this side? They're congruent. So v divided by 3 is equal to 6. If I have v divided by 3 equals 6, what kind of problem is v divided by 3? Addition, subtraction, multiplication, or division?
Division.
Division. How do I undo division? Using multiplication. So what do I multiply by?
3.
Multiply both sides by 3. Those 3's cancel, so v is equal to 18. So if v is equal to 18, then what is the measure of this? 6, because 18 divided by 3 is 6. And notice that it already told me that the top part is 6 as well. Okay. So you're using the relationships that we've just talked about. What do I know about, let's see, 33. Look at 35. I have variables of B, C, and D. How many variables can I solve for at one time? 1. So I've got to look at the relationship between the angles that have the same variable. Which of those have the same variable?
B.
B minus 10 and B plus 10. What do I know about the relationship of these two angles?
Oh, they are consecutive.
They're consecutive, so that means when they add together, they equal 180. So I can set up B minus 10 plus B plus 10 equals 180. Once I have solved and I know what the measure of this angle is, then I know D. When I know what the measure of this one is, I know C. Okay, so whenever I have multiple variables in a problem, I've got to look and see which ones can I work with first. And then when I solve that one, I can solve the others. Okay, so we've still got 30 minutes. I think what I want to do, let's go ahead and look at 6.3. We're not going to have homework on 6.3. We're just going to look at it. I think probably by the time we look at 6.3, we should probably be done with this in the next 15 minutes, which will actually give us 15 minutes to get started on homework. So we're going to go over 6.3. We're going to talk about it. We should have time to start our homework, and then I'll also pass out our tests. So hopefully you can get a bulk of your homework done, or at least started, and then your test, and all of that will be due when we return from Thanksgiving, okay? So let's take a look at this. All right, so remember our theorems. If both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. If both pairs of opposite angles of a quadrilateral are congruent, then it is a parallelogram. If an angle of a quadrilateral is supplementary to both of its consecutive angles, then it is a parallelogram. If the diagonals of the quadrilateral bisect each other, then it is a parallelogram, okay? So just like we talked about in 6.2, we said, hey, if it's a quadrilateral, it's got these things that are true. Now we're saying if these things are true, then it's a quadrilateral, okay? So we've just looked at the converse of each of those. So what we're gonna do is we're just gonna look through these proofs, okay? So it says, given that AB is congruent to CD and AD is congruent to CB, we're trying to prove that ABCD is a parallelogram. So that we have our given first, but then notice that they have a diagonal. So AC is congruent to AC using the reflexive property of congruence, okay? So I have now, if I'm looking at this, if I know that this side is congruent to itself, I have side, side, side congruence. So then, because I have side, side, side congruence, I know that the angle of angle BAC is congruent to angle DCA, and angle DAC is congruent to BCA. And that's because corresponding parts of congruent triangles are congruent. Also, I know that side AB is parallel to CD and AD is parallel to CB because of the alternate interior angles converse. So think about going back to alternate interior angles. If you need to draw your figures like this, if it helps you to see it better and you go, oh, I've got parallel sides and a transversal, that means that alternate interior angles are consecutive. If you need to draw it out to see it, that's just fine. Therefore, since the alternate interior angles, since my opposite sides are parallel, I know that ABCD is a parallelogram using the definition of a parallelogram. All right, so it says, as the sewing box below is opened, trays are always parallel to each other. So you can see when it's closed, and then you can see as it's opening, all of my sides are always going to be parallel. So I've got parallel sides here. These sides are parallel, these sides are parallel. So as the box opens, it's never intersecting with each other. It will always stay gliding out in the same slope. Okay, so then that way they never overlap. Therefore, it will open all the way. And that's all we're going to say about that. All right, let's go ahead and look at theorem 610. If one pair of opposite sides of a quadrilateral are congruent and parallel, then the quadrilateral is a parallelogram. So what is the difference here? What is the key here that we're saying that I can judge it based on one pair of opposite sides? That they have to be what? Parallel and congruent. Because notice if I just had this figure, okay, if I've got that figure, notice that these two sides would not be the same length. Neither would these two sides, so I could not assume. But notice it says if they are congruent and parallel, then it's a quadrilateral. That's why we have the arrows and the red hash mark, because it's indicating congruence and that they're parallel. So here they have a flow proof. We are given BC is parallel to DA. BC is congruent to DA. We're trying to prove that ABCD is a parallelogram. So we have our given, And then we have our alternate interiors angles theorem that DAC is congruent to BCA. And because of, as well as AC is congruent to AC and BC is congruent to DA. All of those lead to triangle BAC being congruent to DCA because of side-side-side congruence. Because of side-side-side congruence, I can tell that AB is congruent to CD, and that's corresponding parts of congruent triangles are congruent. Therefore, ABCD is a parallelogram. Okay.
Flow proof.
Huh? So this is a flow proof, yeah.
That sounds fun.
So we've been able to see different things about our parallelograms. Now notice also, look at example 4. Using properties of parallelograms. If I have points A, B, C, and D, and A is 2, -1, B is 1, 3, C is 6, 5, and D is 7, 1, I can plot those on a graph. Okay? So if I plot them on a graph, notice that I can look at these and there's 2 ways I can prove that my blue sides are congruent. What 2 ways could I use? I could do one of 2 things. What do we think about when we're using our graph and we're trying to find the length of a side? If I'm trying to prove that these 2 sides are congruent, okay? I mean, not congruent, that they're parallel. Huh? If they have the same slope, remember parallel lines have the same slope. So how can I find the slope of a line? Slope formula, which is M equals
X minus X. Yep.
what's in the numerator?
Y.
Y is in the numerator, the difference of Y over the difference of X. So Y2 minus Y1 over X2 minus X1. Slope formula. So I can find the slope of each of my blue lines. If they are the same slope, then they are parallel. Same thing with my red lines. If I can use the slope formula to prove that the slope of this side is congruent to the slope of this side, then they are parallel lines. So I can use the slope formula. Now to find distance, to find the length, I can use the distance formula. Okay, so if you look at our solutions here, the first thing we can do is find the slope. So we can see that the slope of AB is -4. The slope of CD is also -4 because they use the slope formula there. The blue lines, BC, my slope is 2/5. DA, my slope is 2/5. Again, parallel lines have the same slope. Therefore, they are parallel. Now it says you can also show that opposite sides have the same length. Here I'm using the distance formula. Remember with our distance formula, we can set that up. And so you can see, let me get it to where we got our ordered pairs. So again, when we use our distance formula, we've got, there we go. We can use our ordered pairs here to plug in to the distance formula. So we can see that AB is equal to the square root of 17. CD is also equal to the square root of 17. BC is equal to the square root of 29, and DA is equal to the square root of 29. Therefore, parallelogram. The other thing says we can show that one pair of opposite sides is congruent and parallel. So remember, we can either show that 2 opposite sides are parallel. So that means we've got to do it for both sides. We can show that 2 sides are congruent, or we can show that we have congruent and parallel of just 2 sides. So you can find the slope and you can find the distance. All righty. So what we will do is we will, when we get back from Thanksgiving, the main thing that we are going to review is this goal 2. So this is where I'm going to mark start, and that will be on 11. Ooh, no, actually that will be at December.
So
Let me look at our calendar. Okay, so December in class. So 12-2, we're going to start by going back. Goal 2, using our coordinate geometry to prove that a figure is a parallelogram. Okay, so we'll start here. So you've got your homework assignments. I'll get ready and pass out the test. Make sure you put your name on it. You can go ahead and start working on your homework and then ask questions if you need to. Okay. You guys online, if y'all want to do the same, y'all can chime in. If you just want to log out and work on your own, it's up to you, or you can stay logged in. Then that way you can ask me, just unmute and ask me if you have questions. I will go ahead and get ready and send y'all. Let me take a picture of the test and I'll send it to you. I'll apologize in advance because the scanner app is really loud. I have no way to turn it down.
Is it? Don't suspect trying.
I just emailed you guys the tests. Oh, the test. And I got a board on the back. Really quick, we can look over it. So number 1, you're using the diagram to tell measures. Okay. You're using the diagram to tell measures. So notice that my figure has been cut into 2 triangles. What types of triangles are each of those triangles in numbers 1 through 3? On the test, look at numbers 1 through 3. What kind of triangles do I have? And the top 2 where I have ABM and CBM. What are those?
Equal.
We've got right triangles because they have a right angle. If I have 2 sides of a right triangle, how do I find the third side? If I have 2 sides given of a right triangle, how do I find the third side? Pythagorean theorem, a squared plus b squared equals c squared. Okay. So you were having to you're finding the distance of CM. you are finding the distance of BC. It says BM is a perpendicular bisector of AC. So because AD equals CD equals 17, what can you conclude about point D? Okay. Exercises 4 through 6. Complete the statement with the words inside, on, or outside for perpendicular bisectors. In a right triangle, the point of concurrency is blank the triangle. Number 5, in an obtuse triangle, the point of concurrency is blank the triangle. In an acute triangle, the point of concurrency is blank the triangle. So think about when we talked about points of concurrency. Are they inside, on, or outside the triangle? 7 and 8, we're using our diagram to tell measures. Number 7, the perpendicular bisectors of triangle ABC meet at point D. So find the measure of BD and find the measure of DC. Numbers 9 and 10, draw an acute triangle with 3 angle bisectors. Think about acute triangle. Think about what a bisector looks like, an angle bisector. Number 10, draw a right triangle with 3 perpendicular bisectors. 11 through 15, you were writing the answer always, sometimes, or never. The perpendicular bisectors of a triangle will blank intersect on the triangle. The angle bisectors will blank intersect outside the triangle. The medians of acute triangle will blank intersect inside the triangle. The ends of an obtuse triangle will blank intersect on the triangle. Number 15, the perpendicular bisectors of an obtuse triangle will blank intersect outside the triangle. So again, you may need to draw diagrams to help you check these and see, is it going to be always, sometimes, or never? Turn it over on the back, you have a figure, you're finding measures, 20 through 22. What type of figures do we have here? What are these lines drawn in the middle or inside our triangles? What do we call those? 20, 21, and 22. What do we call those lines drawn inside our triangles? Are you looking at number 20, 21, and 22? Those are mid-segments. Think about, what do you know about a mid-segment? 24, list the sides in order from shortest to longest. 25 and 26, list the angles in order from smallest to largest. 27 and 28, you're using the hinge theorem, okay? Remember, hinge theorem is going to be less than, greater than, or equal to. So that will be what you're using in those answers, greater than, less than, or equal to. Yes. Okay, so any questions about the test, anything that you're not sure about? Look through your notes before you start the test. Look at your points of concurrency, review angle bisectors, perpendicular bisectors, medians, altitudes. Think through each of these things that we have talked about, dealing with our lines that intersect in a triangle. Okay. Question about the homework. What you got?
137.
Okay, so it tells me that it's a parallelogram. So think about my rules about a parallelogram. Okay, so remember, I've got to start by relating the things that have 2 variables the same. Which ones have 2 variables the same? T is the same. What do I know about the relationship between this angle and that angle?
They're opposite.
They are opposite, so that means they are what?
Equal 180.
No, those are corresponding. Look about opposite angles of a parallelogram. Where do we talk about opposite angles? Are congruent. What does that mean? How can I set that up as an equation?
Oh, so I'll write 3t minus 15 equals 15.
There we go. And then solve for t. Then once you've solved, you can find the measure of this angle and figure out what this one is by doing what?
Oh, I see it.
You add them together to equal 180. Same thing here and here. Okay, so once you've solved these, you can figure out 4R and 3S.
Thank you.
So I set this equal. That equal, so I did that. But it was wrong.
Okay,
S
so
equals 40, so
let's take a look. All right, so you solved for 37. What did you say t was equal to?
25.
Okay, so if t is 25,
Yes.
then what is the measure of this angle? What is 3 times t?
75.
Minus 15. Okay,
Oh,
60. So if this angle is 60, you've got 60 plus 3s equals 180. So 60 plus 3s equals 180.
It makes sense.
Okay.
We'll say 35.
That's what I'm saying.
So
So
now,
now,
oh, yeah.
if s is 40, what is the measure of this angle?
Whoa, 100,
120. So what does that mean the measure of this angle is?
120,
So what is r?
100.
4r is
Oh,
120. So what is
30.
r?
30.
You're having to use the information you know to apply it to be able to solve for just the variable. Okay, so like on this one, so you're good, except for all you gotta do now
It's right now.
is write your notes and then check it. If you miss nothing, then -0 at the top, and then that way I know that there's no corrections needed. Okay, if you miss something, then you'll make your corrections. Sure. So,
With me, I'll go ahead and I'll have vertex and an endpoint. Not all of my.
okay, so look at if I have M, okay? I know that the 2 places I cannot go are to L and to N, right? Because those are consecutive. So I could draw a diagonal from M to T. I could do a diagonal from M to S. M to R is D. I could go M to Q, M to P. Okay, so those are all the diagonals that I could have. M to T, M to S, M to R, M to Q, M to P. Okay, but I couldn't have the side to sides because those are not diagonals. Those are sides.
Oh. It's cool. That's cool.
Always makes gay jokes.
It's funny.
You doing okay, Keith?
Alright, so,
Okay.
800. 69. I didn't know you were upset when I was-
I'm gonna send you 3 pictures and you choose one that will forever be your icon.
Okay, but.
There's sign for the video.
It's very sharp, that's what it is. That's funny.
Yo, here, what's our advice line? Reads only ends now.
Do what?
My clients are doing,
I'm not here. Did you send 5? I didn't send 5.
can't be weird.
Yeah, that's pretty easy.
I was just making sure.
Yeah.
Oh, we got ready.
Actually,
Yes.
I have one question.
Okay.
Between that. Would that be equilateral? I want to equal. Actually, could be nice because it is concave.
What does equilateral mean? What does the word equilateral mean? Sides. Are all those equal sides?
No, this is mine.
Well, wait, look at it. Why did they put those red marks there? Remember, the red marks are telling me that they are congruent. So if the red marks are there, it says this side is equal to this side, which is equal to this side, this side, this side. These are all the same. So it is equilateral. Are my angles all the same?
Yes, it's regular.
Hold up. Why are you saying they are the same? Have they marked the angles to tell me they're the same? No, remember, I have to go based on what they've marked. Here, they mark that all my sides are congruent. They've marked that all my angles are congruent. Therefore, it would be regular. On this one, they have only marked that sides are congruent. I cannot assume that my angles are congruent if they did not put the symbol there, okay? So, is it gonna be equilateral, equiangular, regular, or none?
Equilateral.
Equilateral, good.
You still leaving?
Huh?
I can hear it. They're all great pictures.
Oh.
Oh. Okay. so
And also, don't forget your chapter 4 corrections after Thanksgiving as well. Alrighty, so it's about time for the bell. So we'll get ready and close up. All right, you good, Keely? Any questions before we go?
I think I'm good right now. Thank you.
Okay, let me know if you need any help. I hope you have a great Thanksgiving.
You too. Thank you.
Bye-bye.